Okay, it's saying I'm live. That's cool. All right, we're back. It's been an hour. Okay, so the mold is about 200 degrees right now, 200 Fahrenheit, and I'm just sort of letting it turn until it's vertical rather than um, use the air brake, which I might end up doing anyway. We'll see. All right, putting my gloves on, and I'm making it protect my arms with the sleeves. We're going to have to pull the screws out that hold the inserts in place. So as the tank pulls, you might hear it click, and that's when plastic is releasing from its surface, the surface of the mold. Oh, Joe, I forgot I need to unlock the arm anyway because I have to get at the side. So on these screws, it's especially great that my sleeve overlaps with the glove because you have to reach inside, and it's like I have a lot of burns right below where the gloves go. So there's 10 6mm inserts that I use the number 3 on, and then there are 3 5mm inserts and 3 4mm inserts that we use the number 2 Phillips on. So there are springs on the screws to the outside, and that's so that when as the part is molded and it cools, it allows the inserts to pull away from the edge a little bit. So when the plastic contracts, we don't end up with these raised points where the inserts were rigidly held against the frame or the mold. So we have all the inserts screws out. Now there are 2 pins. We call these pull pins, Pull, like we're pulling on it. We learned that you need to have the temperature under 165 degrees for the pins to pull out. Otherwise, they might disturb the plastic. So this part right here is the base of the tank that goes between the rider's legs. And so this screw holds the pull pin in place for the mount. And that pin is right here. $152, $153, $155. Okay, we could do this one. This will be unique to this video. I'm going to do a little bit more of a close-up on how to pull this pin out. The first thing to do is you want a real quick twisting motion to unsnap plastic from metal. And so the metal has mold release on the aluminum, the pins, everything the plastic touches. And so right now it has a very airtight grip. So you're going to hear a pretty loud snap, and that's exactly what we want. Perfect. People will try to get fancy when they make molds with their pins, and I just use grade 8 zinc wash bolts. They work really well. Like, they're great about letting go of the plastic. And they're easy to machine. So that's the profile of the mount. And then where it tapers down at this end, it actually rests inside of something making the same kind of feature at the other end. And that piece is actually over here. So what I had done was to kind of repair this whole area. I set up the mold on my vertical mill on its side, and I bored through with a 3/4 inch fitting. And then so this is a 3/4 inch sleeve onto a 1/2 inch bolt. And then this side too, I made the receiver that plugs into. Before, they had two pins try to meet in the middle, and it always created air bubbles or pockets or problems. So rotational molding is all about the flow at the surfaces where the plastic touches. So that fixed the problems we were having there. Probably this next pin is going to be too hot. Yeah, it's still 175 in there. Normally we'd have two tanks being made, but we're only making one. To save time, we have a couple of the HM69 tanks on the shelf. So to make it less torturous, to make just the monster tank, we're not loading the other mold. And this one's the one we're focused on right now. If I have a water bottle somewhere, I could spray water at it to help cool it. I don't see that though. guess I could take a second and talk about controls. So this is the hand control for the motor. It's like a variable speed drive, VFD or variable frequency drive. And we want to go at 4 RPM on the shaft. So we have this motor here is 1725 RPM at 60 hertz. We have a 72 to 1 gearbox here, and then we have a 15 to 60 1 to 4 reduction with the chain. And that results in the arm being approximately a tenth of the frequency of the motor. So it's at 39.9 hertz, and that's about 4 RPM. And the way this does its magic is with a higher frequency and I'm trying to, it's like I think it uses like a beat frequency out of the higher frequencies. I'm not entirely sure of the voodoo magic, but it lets you get great torque at lower RPM. And so right now we're only running 2.5 amps to turn that on. So even though it's 1.5 horsepower, it's typically 5.3-ish amps at 208 volts. So we're at like half of its power. Now we're going to stop and check the temperature again. Yeah, the highest I could get was 164 on that pin, so we're good to go with that. So inside the middle of the shaft itself is an axle, and so this part inside the end here is a gearbox, and it's a 1 to 4, actually 1 to 3.97 for this counter gear reduction. And at the other end is an air brake that holds that shaft in place. So I can reach my arm in. Stop. Okay, there we go. So reach my arm in. Look, I need to loosen this screw on the outside first. So instead of a trying to think of the word. Oh, instead of a 1/2 inch bolt, we use a 5/8 inch bolt for that pin, and it uses a 15/16 head. And so we have this tool dedicated for that use, and it's in the toolkit for this mold. And this is the pin that makes the drain that goes underneath the filler cap. So now there's nothing holding the mold to the part. So we had to do all of these other steps because the screws for the inserts, the pins for the passages, all that stuff makes the mold attached to the plastic. Now there's nothing holding the mold and the plastic together. So this part's a little bit tricky because you need to get that um, top mold piece off of the tank without dinging the tank. So when you pull it away, you've got to pull it away. You can't hold back. You can't let it hesitate. None of that stuff. So I have another table set up underneath it all. Like your tripod is there with the computer, and I have my other table there. I'm gonna undo the mold bolts. So I like this impact driver for this purpose. I might actually get a 3-inch drive impact and not have an adapter. I don't know. Well, I mean, we use that other thing, so I guess we do want to keep the adapter or keep the 1/4-inch heads. But I like that tool because it has step settings. We use it on the middle setting or 2 to tighten the screw, and then we use 3 to remove. You don't need much force. The more force you use, it's kind of like worse because then you're going to start squishing the aluminum out. So each of these boxes has a steel square inside to spread the load out, and on the back are receptacles for nuts. I want this a little bit towards me. Oh yeah, we got it. Wow, that looks great. We're starting to see some ghosting from, like as the mold release kind of wears in, you'll start seeing hazing happening. And then when it starts getting really white, that's when you need to do a new mold release. And that wastes an entire production because you have to get the mold up to 250. And then the sucky part is then you have to bake the stuff on through a full cycle. Plus, you have to smooth it out so you keep your shine and you don't see the streaks from the mold release. I think there's a video on that. So the plastic's about 187. And we've got about 118, 122. So we got 122, 187. And I'll take another measurement underneath. And 183. So what I say, 122, 183. I write down the demold temperatures. So on my logbook, I record the temperature at warm up after 30 minutes at 530, which is 418. 30 minutes of fan, and it's 203, and then demold. The outside of the mold's like 122, and then the plastic is 183. And I keep track of these. Consistency is kind of king with rotational molding. And since it gets to about 90s or 100 during the summer, I go ahead and put a little bit of heat in the tools before I start so that we're using the same difference in calories for all the baits. think they said that's normalizing the temperatures. So here are molds on this table. There's you, the computer. There's me. And now what we're going to do is we're going to pry the tank out of that. And then we're going to do the cooling fixture so that the tank cools and it looks great. So here I just put a 1/2 inch extension that's dedicated for this tool. I put it through the mount and it pops loose from the bottom piece of the mold, or the bottom mold section. So this gets pretty miserable in the summer. Like today we started and it was 60 degrees. And I haven't quite broke out in a sweat yet. This piece serves two purposes. One is for the cooling, and the second is to protect. It's a drill guide to protect the rest of the tank when we use the giant hole saw. Because if it grabs and skips out, it'll ruin the surface where the O-ring goes. Now, a cooling fixture helps hold the plastic in place as it cools, because as the tank cools, it shrinks 2%. The other thing, it's a thermoset plastic, so the first cooling cycle defines the shape forever, and that's it. You can't change the shape again. You can have temporary deformation due to heat or pressure. However, you can't melt and reflow the plastic. This configuration it's in now is its forever matrix. Right now, the space between the two tank pads is too narrow. We built the tanks too narrow for many years, and then it occurred to me I could put something between them and shove them apart and then have proper spacing. And we did just that. I used some all thread. On one end is a trapped um, square washer, and at the other end is a free square washer. And I make sure that these square washers are tight against the screws. Now there's a little bit sticking out. That little bit of thread past the end. We're going to make that disappear, and then it'll be level with um, the plate, and then that's perfect. Then when the tank cools, it'll be the exact width we want to fit on the frame. in the setup for taking it apart or removing this, I go ahead and change the tool to the next for its next use. The date dial came out great. We actually didn't treat it with anything. It came with Teflon. And in fact, what's kind of interesting is that there's coining on the date dial itself. So that means it's pretty slippery. It's so slippery that the plastic, as it glassed and flowed over that flat surface, it trapped a bubble and stayed that way. Coining is not a problem if it doesn't ruin the functionality of the tank. So in this case, the only function here is looking at the date dial, and the arrow and the year are still legible, so who cares? If coining happens right in the middle of the tank, well, that's an eyesore and makes the tank kind of not sellable. If the coining happens where something needs to seal fuel, then the tank is functionally ruined. So coining happens if there's too much mold release. So we're always very careful about the coining. Like after you do the mold release application, it's kind of normal that the first tank that you make is going to have coining. So you probably expect that one's going to be throwaway. We run the recirculation and intake and exhaust fans until the temperature of the oven is down to 200, and then we can turn those off. You probably can't tell much because this microphone is awesome, but it's a lot quieter. All right, that was kind of it. I'm so glad that new Fire Eye works. I was really, really worried. I hate when our things break. And then I really didn't like that there was no smoking gun with the failure of the piece. We've got a line on a replacement programmer module to go in our original Fire Eye. It's $80. I'm trying to get it going from an eBayer. Been kind of tricky. He doesn't want to do shipping. I'm trying to email him a label and all that. Not easy. If we can get that in, I'm going to put it in the original Fire Eye, and I'll swap them back out and see if the original one works. That'd be pretty great because then we'd have a backup. Anyway, that's that. This is MTT tank number 124. So it's the 124th one I've made here in Georgia with the oven. And I think we did about 400 plus. I want to say we did like 400 plus when we were in San Diego. That was via another molder. Anyhow, thanks for watching. And that's that part. We're going to let it cool. When we come back on Monday, we're going to undo the cooling jig. We're going to drill the hole. We're going to pressure test the tank, then finish trimming and prepping the tank so we can ship it out Monday. Thanks so much. Bye.